Hi everybody. We're going to have a quick look at differentiating f of x plus or minus g of x. So if we have an expression like an equation or a function, in this case, like y equals 2x squared plus 3x plus 4, to find y prime, the first derivative, we differentiate this and this and this separately, and they will go together to make the first derivative. So, for instance, if we were given y equals 2x squared plus 3x plus 4, according to this rule, we would differentiate this, and in fact differentiate this, and then we can put them together to find the first derivative. So our question here asks us to find the first derivative, find the instantaneous rate of change, find the tangent at x equals 6, and find the average rate of change from 0 to 6. So let's do the first part. Times the index by the coefficient gives us 4x, reduce the coefficient by 1. That's this part here. That becomes 3. That becomes 0. The first derivative is 4x plus 3. Easy enough. Then to find the first derivative at x equals 6, or y prime 6, substitute 6 in where x is. 4 times 6 is 24, plus 3 is 27. To find that, so that's this question solved. To solve this question, we need the tangent at x equals 6. Got to be careful with this, because we know what x is, we don't know what y is yet, so to find out y we can substitute into the original equation. And then use that to help us find the equation of the tangent. So let's do it. y6, put 6 in here and here, end up with 94. So when x is 6, y is 94. We know that 6 and 94 lie on the curve, and the gradient at that point is 27, worked out from here. So substitute 94, 6, and 27 into y equals mx plus c. Solve for c, we get negative 68. The tangent line is 27x takes 68 at x equals 6. Now, if we wanted the average rate of change from x equals 0 to x equals 6, we would need to know the y value for 0 and 6. y0 is 4, 0, 0, 4. y6, substituting in, 6 squared is 36, 72 plus 18 plus 4, which gives us 94. Subtract to find the average rate of change, take the difference in y's, divide by the difference in x's. 94 take 4, 6 take 0, gives us 15. And that's the answer for D. Now, if that was in a non-calculated section, you have to do all of this. But if it's in a calculated section, you have to be really careful, because if you do all of this, you'll run out of time to solve your exam question. So you need to know how to use your calculator properly. So let's do that quickly. So I've taken this expression here, and I've just written it here, and it's spat it out. Then I used d on dx answer, so that's the previous line, to get the first derivative. So to do that, let's make sure we know how to do that. Where'd my little thingy button go? Missing a window. Keyboard. Here we go. So go to your Math2 template, d on dx, put the x in here, and your answer is down here. Hit return. That will give you that one. Now, so far we're up to here. Now we're going to substitute 6 into the previous line. So substitute 6 into the first derivative, gives us 27. That's this value here. Find the tan line function. You go interactive, calculation. What was it? I've forgotten where it is. Interactive, down here, line, tan line. And again, we need to put in 2x. You can copy and paste this if you have to. Plus 3x plus 4. And we're wanting it to do it at 6. and it will just spit out the equation. There it is there, just like we found out. Now, if we're wanting to find out the rate of change, we would need to know the y value at 6 and the y value at 0. Construct a little equation, 94 take 4 divided by 6 take 0. Don't forget the brackets in the right places. And like here, you'll get 15. Now to do all of this, it's a mile quicker than doing it by hand. So make sure you use your calculators properly and know how to use your calculators. For the rest of the examples though, I won't use a calculator, I will do it all by hand because that's where these questions typically will sit, in a non-calc section. So this says find the gradient where f of x equals x squared take 4x plus 3, find where it cuts the x and y axis. Well, the derivative of this, because we're finding gradients, we need the first derivative, the instantaneous rate of change. That will be f prime x equals 2x minus 4, 2x minus 4. Cuts the y-axis at x equals 0, so substitute 0 into the first derivative, and you'll get minus 4. So that's the gradient at x equals 0 for the y-intercept. Now, if we're doing the same for the x-intercepts, we need to know where it crosses the x-axis, so that's when y equals 0. So we take this equation here, equate it to 0, factorize it, solve it, and we get x equals 1 and x equals 3. Substitute those into the first derivative, and we'll get negative 2 and 2, this being the first derivative. And then we make a statement. At x equals 1, the gradient's negative 2. At x equals 2, the gradient's 2. We have to make sure that we always answer the question given. Third one. This time, given this equation, find out where the gradient's 12. So first we need to find the equation for the gradient, for the first derivative. 6x squared takes 6x, that becomes 0. At dy dx equals 12, substitute it into here. Now note, if they've listed dy dx here, I've used it here. If they've used f of x, I've used f prime x. If they've used y, I've used y prime. So you keep the notation the same, in the same format that's been given in the question. Alright, back to this question. So we know the gradient's 12, so 12 equals 6x squared takes 6x. The rest of the equation, all I've done is put 12 where dy dx is. Rearranged it, factorized it, simplified it, rearranged it, solved it, got x equals 2, x equals 1. Now I probably should have found y for each of these, but I didn't bother. You should do it though. So, find x for stationary points of y equals x cubed plus 2x minus 1 and y equals x cubed plus 2x squared take 5x take 6, and find the location of the point of inflection for b. So part I. Here's the graph. We can see that it has no stationary points. Let's see if the algebra shows that. Y prime equals 3x squared plus 2. Let y prime equal 0, so find out where the gradient 0. Equate this to 0. Try and solve it. There are no solutions or no non-complex solutions. If you're doing specialist, you'll learn about complex numbers next year. But if no solutions exist, there are no stationary points. For b, we can see from the graph that there are stationary points this time. So I've taken the derivative of this, 3x squared, 4x minus 5, 0. The stationary points are where the first derivative is 0. I've equated this to 0 by replacing this with 0. 3 times negative 5 is negative 15. There's no easy factors of negative 15 that add to 4. So I use the quadratic formula, which gives me negative 2/3 plus or minus root 76 on 6. So the stationary points are at x equals negative 2 on 3 plus or minus root 76 on 6. We would never be expected to substitute that back into this equation to find the y parts. For that equation, it would be too messy, but if it was in a calculator section, you would be expected to do it. Now, a cubic has rotational symmetry, so it'll rotate around this point here, the midpoint between this and this, which funnily enough ends up being this, because negative 2/3 plus root 76 on 6 would be back to here. Negative 2/3 plus root 76 on 6 would be up to here. So, given that, and they've asked us for a point this time, we've got to work it out. So we're going to sub in negative 2/3 into this equation here to find the y-coordinate, which we find out is negative 56 on 27, and therefore we make a statement the point of inflection is at negative 2/3 negative 56 on 27. Last example, find the gradient of the curve where this curve meets this line. So they cross when the y-coordinates are identical, so we can equate the x values together. We end up with this quadratic, we solve it, we find out they cross at negative 2, negative 1, which is consistent with the graph. We need the gradient at negative 2, negative 1, so find the first derivative of this, which gives us that. There's no point in finding the gradient of the line because we know it's 1 just by looking at it, and it's not what the question asks for. So we have 2x plus 4, substitute in negative 2, we get 0, which is consistent with the graph. Sub in negative 1, we get 2, that's a positive gradient consistent with the graph. So then we make a statement, the gradient where the curve and line meet are at x equals negative 2, the gradient 0, and x equals negative 1, the gradient is 2. And there we go. I hope those 4 examples were useful and help put your concepts together in a nice, neat framework. Thanks, everyone.